Astronomers are tracking a newly discovered object in space.
What if the universe has been catfishing us this whole time? Well, the Webb telescope just called it out. And now space has some serious explaining to do. Scientists are officially baffled. Thanks to the Webb telescope's ultra-deep, high-def galactic selfies, we're seeing things that make even seasoned astrophysicists do a double take. Galaxies are popping up where they shouldn't be. Cosmic timelines are bending like pretzels, and theories we've clung to for decades, like dark matter, dark energy, and the sacred story of the Big Bang's microwave afterglow, are suddenly looking wobbly. As Andrei Kutow from Lawrence Berkeley National Laboratory said, "We're in the business of letting the universe tell us how it works, and maybe it's telling us it's more complicated than we thought." Today we're going to break down the cosmic confusion and figure out what in the multiverse is going on, because we might need to rewrite the universe's autobiography. Let's start with a discovery from the groovy 1970s. Astronomer Vera Rubin noticed something suspicious while studying how stars move inside galaxies. Imagine checking out a merry-go-round and realizing that the horses on the edge are spinning just as fast as the ones near the center. That's weird, right? In theory, those edge stars should be flinging themselves into deep space like cosmic frisbees because gravity out there is supposed to be weaker. But nope. They just kept spinning around like they'd had a double espresso. There had to be something, some hidden force keeping those stars in check, something invisible, mysterious, and stubbornly uncooperative with telescopes. So they gave it a name that sounds straight out of a sci-fi thriller: dark matter. It doesn't glow, it doesn't reflect light, and it doesn't pay rent. But it might just be holding the entire universe together, like duct tape on a collapsing bookshelf. According to the standard model of cosmology, once regular matter came into existence, dark matter stepped in like a cosmic construction manager, pulling stuff together with its gravity and building the first stars, galaxies, and those sprawling galactic highways we now call the cosmic web. What has the Webb telescope been seeing out there? Frankly, it's blowing our scientific minds. It's finding galaxies way farther and way earlier than anyone thought possible. We're spotting galaxies that existed when the universe was around 280 million years old, with a few unconfirmed candidates suggesting even earlier formation. That's like finding a full-grown tree in a nursery. It challenges everything we thought about how fast galaxies could form. And here's the kicker. These baby galaxies aren't small. They're not messy. They're not acting like cosmic infants at all. Some are surprisingly organized, mature, and full of older stars. These galaxies are much larger and brighter than anything we expected to see so early in cosmic history. These early universe galaxies are making dark matter look suspicious. If dark matter was supposed to be the scaffold that held everything up while galaxies formed slowly over billions of years, then why are these massive, mature galaxies already out there, barely a couple hundred million years after the Big Bang? In a recent analysis of thousands of early galaxies detected by Webb, scientists found something extremely strange. But there's a twist to this story. Some galaxies that appeared overly massive were actually powered by black holes rapidly consuming gas. The friction in the swirling gas emits extreme heat and light, making these galaxies appear much brighter than if the light came from stars alone. Scientists nicknamed these little red dots, objects whose brightness was inflated by black hole activity, not stellar mass. When scientists remove these deceptive galaxies from the analysis, the remaining early galaxies are not too massive to fit within our standard model predictions. But we're still seeing more galaxies than predicted, although none of them are so massive that they break the universe. The evidence suggests that maybe in the early universe, galaxies were better at turning gas into stars than they are today. Now we get to some serious cosmic detective work. There's something called the S8 tension, the universe's version of a glitch in the matrix. S8 is basically a number that tells us how clumpy matter is in the cosmos, particularly across the largest cosmic scales. Here's the problem. When scientists measure the early universe using data from the cosmic microwave background, they calculate a nice tidy S8 value that fits perfectly with our current cosmological model. But when they turn their telescopes to today's universe and measure how galaxies are actually spread out, they get a significantly lower S8. It's as if the universe told us one thing at the beginning of time and is now giving us a completely different story. There's also the Hubble tension. Scientists are finding that how fast the universe is expanding depends on how you measure it. When we peek into the ancient past using the cosmic microwave background, we get one value. But when we measure the nearby universe with supernovas, we get a completely different number. This galactic disagreement isn't just an awkward family argument, it's a full-blown cosmological crisis. Some astronomers now think that dark energy might not even be constant. That's right. The one thing we thought was unchanging might actually be evolving over time like a moody teenager. Some researchers have proposed that dark energy might evolve over time, and ongoing Webb observations could eventually provide insight. However, Webb has not yet directly detected any change in dark energy behavior. The apparent difference in expansion rates comes from measurement techniques, not confirmed dark energy variation. But what if there's a simpler explanation? Scientists have proposed a new model called timescape cosmology. In this model, the expansion of our universe is not driven by dark energy, but is an illusion created by time. They propose that time flows slower in regions of space where the concentration of matter is higher. An atomic clock situated within a galaxy might tick up to a third slower compared to an identical clock positioned in the middle of a vast empty void. Over the vast timescale of the universe, billions of additional years may have passed in cosmic voids compared to matter-rich regions. Since so much more time has passed in the voids, these regions have experienced more cosmological expansion. A recent study using Webb data analyzed the spin directions of 263 galaxies, and surprisingly, about two-thirds of them appeared to spin in the same direction. That's like the universe coordinated a tiny cosmic dance recital. While intriguing, this finding is based on a small sample and doesn't yet challenge the Big Bang model. But it does raise fascinating questions about early cosmic structure. Even more mind-blowing, the further back in time they looked, the more obvious this cosmic spin trend became. Galaxies from the early universe showed even more alignment. It's like the deeper we peer into the past, the more the universe starts acting like it had a plan all along. Dr. Lior Shamir and his team dove into this galactic rotation mystery, and their measurements revealed a pattern that completely defies our current models. One of Webb's most profound discoveries challenges who we thought lit up the universe. For years, astronomers believed massive galaxies and supermassive black holes were responsible for cosmic reionization, the process that ended the universe's dark ages. But Webb has revealed that faint dwarf galaxies, small but surprisingly powerful, were the true drivers of cosmic dawn. Despite their tiny size, these low-mass galaxies are prolific producers of energetic radiation, and their abundance during this period is so substantial that their collective influence can transform the entire state of the universe. It's like discovering that ants, not elephants, built the pyramids. Remember the cosmic microwave background, that faint, all-encompassing glow we called the afterglow of the Big Bang? New research is suggesting this might not be exactly what we thought it was. While early galaxies do emit radiation, the cosmic microwave background, CMB, is almost entirely relic radiation from the Big Bang's afterglow. Any contribution from galaxy light is part of the cosmic infrared background, not the CMB. Current research does not support the claim that early galaxies significantly affect the CMB's energy. What if the entire universe is actually inside a black hole? According to researchers, our universe might not have been born from an infinitely dense point in a fiery bang, but rather from the other side of a collapsing star, a black hole that bounced. Gravity can crunch matter down to unimaginable densities, but it doesn't have to end in a singularity. Instead, that matter might rebound, launching a whole new expanding universe. The cosmic edge would be the black hole's event horizon, a barrier beyond which we can't see. This connects to Nobel Prize-winning physicist Sir Roger Penrose's concept called conformal cyclic cosmology. According to Penrose, the Big Bang wasn't the once upon a time of everything. Instead, it was more like the opening scene of a new season in a never-ending cosmic series. Each universe, or eon, ends not in fire and brimstone, but in a cold, stretched-out state. And just as that one winds down, a new one silently kicks off. We're living in just one chapter of an epic saga that may have had countless universes before ours. Let's recap this cosmic detective story. Webb has shown us galaxies that formed impossibly fast, dark matter that might not work as we thought, measurements that don't agree with each other, dark energy that changes over time, galaxies spinning in coordinated patterns, tiny galaxies that lit up the universe, and the possibility that we're living in a cyclic universe inside a black hole. We thought we were reading the universe's autobiography, but it turns out we were only getting the cliff notes. The real story is far stranger. more complex, and more beautiful than we ever imagined. The Webb telescope is continuing to peel back the veil of the universe, and the next twist in the story could be even wilder. With each new discovery, we're not just learning about space, we're uncovering the fundamental nature of reality itself. What do you think about these discoveries? Are we living inside a black hole? Is the universe part of an endless cycle? Let me know your thoughts in the comments, and subscribe for more cosmic revelations as Webb continues to unravel the universe's greatest secrets. The universe has been keeping secrets for billions of years, and we're just getting started uncovering them.